Really cool color LEDs. Put a 330 ohm resistor on it, and now you have a 12 volt LED. If you replace your oil and generator light bulbs with cool color LEDs, not only do they look awesome, they get your attention, because some of these things can get really, really bright. They got super bright white LEDs. Okay, so you can do some cool stuff with this. You can pull the plain old white light bulbs out and light your whole instrument cluster red, blue, whatever color you want to make the car look cool. What I did with that, the reason I'm passing that around, because I think that the whole thing cost me a total of probably about $2.25. But if you take my test light here, I should be able to put it here. And you notice here I got a red light, but the bulb was green a couple of minutes ago. I've wired this circuit up so that if you reverse the polarity, the LED, now what LED stands for, it's light emitting diode, and the diode is the secret to this circuit. What a diode's job is, it's kind of a one-way valve. It allows current to travel through the circuit in one direction. Okay? If you reverse that current, in other words, if you go positive to negative, okay, the diode will stop the flow of the electrons. Nothing will happen. Unless, of course, you open the switch and you're going to blow the diode up. Okay? But the cool things about diodes is anybody have a car radio when they were younger? They hooked up backwards and blew it up, and that was the end of the car radio? And then you gave it to some guy who charged you $35 to fix it. What he did was he opened up the back of the radio and he found the little tiny diode that you blew up, and he went to Radio Shack for like 38 cents and he bought a new one and soldered it in on the board. So what they've done now is they put in a protection circuit so that when you do it, it trips a relay and then it resets. And I've got one of them on here, this little relay here. If you pump 10 amps through this thing, it's going to work fine. If you pump 15 through it, it's going to flow. And then when it cools down, it's going to close back up and complete the circuit again. These are neat because this one goes in place of a blade fuse. You can actually buy, and I have one in my bag of tricks somewhere, you can actually buy replacements for your fuses that are breakers. Truckers have been using them for years. The trucker blows a fuse, he just keeps going down the road because as soon as the circuit closes, his lights are going to pop back on. Or whatever it is that's causing the problem. It saves them from having to stop, but for us it can save us from having a nightmare. Of course, if the thing pops on and there is a real short, it can pop off again. If you've got something going on, you want to figure out what the problem is. But if you're just working on something and you put one of them in instead of a fuse into a piece of test equipment, it saves you the trouble of having to put it back together. Okay, so this test light has been modified, but a standard test light is a light bulb and a piece of wire. And how many people in here have a standard 12 volt test light? How many people in here don't have a standard 12 volt test light? Here, there's 30 of them in the bag, so help yourselves to them. I found a liquidation site on eBay that I got like all of those for next to nothing, so hold on to them. And
that LED light that you have there.
Yeah.
It glows after you go up there. You have a red.
Well,
red LED.
okay. If you take a diode stops current from traveling in one direction. Okay. So if we hook up the positive lead on the green one to the positive side, and the positive lead on the red one to the negative side, and then you hook the other two leads together, what happens is the current is only allowed to flow in one direction. So if you hook it up in one direction, positive with the clip, and the point goes to negative, the red one's going to light. It's going to tell you, hey, you're on a negative line. If you hook it up the other way around, okay, the green one's going to glow, and it tells you, hey, you're plugged into a positive line.
There's two LEDs there.
There's two in one. It's two diodes in one bulb, if you will, and that one I was handing out. Now this one, and I'll post the name of this one on the website. Anybody ever install a remote starter? That thing came with this, which is the coolest test light in the world. It's got a red and a black clip on it. You don't hook it up to what you're working on. You hook it up to your power source, and I'm going to do it here. Let's see. I'm going to put it here, and I'm going to ground it over here. Now I've hooked it up in this circuit. And you see I got a red and green light. When I go and start probing, if I hit a negative side, if I hit the negative side of the car, it says, hey, all right, that's negative. Green is ground. In in LED and in a couple other things. Electronic circuits that use green wire for ground a lot. Okay, so you start poking around in a wiring harness. I hit a ground wire. I go over here. I hit a hot wire. There he goes. Red one's now blowing all by itself. That's a hot wire. Now this thing here was designed for, you bought your mom a remote starter. It's to make your job easier because you don't care. The thing draws very, very little current. Okay, it draws next to nothing. So it doesn't matter what fuse in the box you put it on. So you grab hold of the harness inside the door and you start poking until you hit the hot wire for the electric lock button. Hey, there it is. That's the one I need. And you hook up to it. I'm going to show you a cool trick for that. If you're just installing something in the middle, okay, you can take an ordinary pocket knife, make a cut in the wire, skin the wire a little bit, make another cut in the other wire, and what you end up with eventually is an opening in the wire. And I'm going to do it with my fingers because I want to save time. Bear with me a second. Okay. These, by the way, are electric cable cutters. These are designed for cutting 10 gauge wire, welding wire by hand. You guys probably never need something like that unless you do stereo installs and you're moving a lot of cable. What I want to do is I want to strip this wire in the center like that. If you want to put in an electrical circuit, you can strip the wire in the middle like that, and the trick is take a point from, say, your test light or something, and wiggle a hole into the center of the strand so that you got even bundle on each side. Okay? Once you get that even bundle on each side, take the wire that you're trying to tap in, put it through the middle, okay? Pull it all the way down to the insulation and twist these wires again. Now just grab the hold of it, take the excess wire and wrap it around and tape it. That connection will never come loose. This wire, you didn't weaken it at all. The new wire, you didn't weaken it at all. So what you've got is a connection that's exactly as strong as it was in the beginning. And you can pull on this one all you want. Once it's taped up, you're not breaking the clock. Okay, so next thing we could use is an electric meter. Now, this meter I've had for at least 20 years, and I use and test it every day in my business. Radio Shack cost me probably 11 bucks back then. You guys all have meters, you look at them. Some of the stuff is obvious, some of it isn't. The RX and then the number after it, okay, that's resistance times something. Resistance is measured in ohms, okay? 1 ohm of resistance isn't very much resistance. If we talk about the water pipe again, you know, if you had 1 ohm of resistance, you're not blocking off hardly anything. Protronix coils, you got to get that, what is that, a 6 ohm coil? Or is it 0.6? Okay, it's less than 1 ohm. What it means is that the circuit inside that coil has almost no resistance. All of the energy you're putting into it passes through it. By the way, a coil is kind of an amplifier. It takes your voltage and amplifies it up. Remember I said you could put resistance on something and squirt the water? You get less water, but it goes further. Electricity, you can make the voltage higher, but you'll lose the amperage. That's what a transformer does. Well, that's also what a